Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is problem 13 on force resolution. Resolve the 180 Newton force into U and V components by the vector approach. The U and V axes are perpendicular to each other. So this approach is using dot product. Remember that one application of the dot product is to compute the component of one vector in the direction of the other. So that's the uh, application of the dot product. And if you want the theory and the concepts as well as the explanation of this topic on early vectors, then you may open my playlist in statics, particularly statics for beginners 1. You can find there the theory on vectors. So this is another playlist which is all about solve problems in statics. So I just apply the concepts and the applications of vectors here. Now, this approach also is applicable if the force is to be resolved into set of axes that are perpendicular to each other. If they are not perpendicular, then use the parallelogram law or the triangle law and the law of sines or cosines. The law of sines especially in computing for the components. So in this case, we can apply the vector approach. So from the figure, the 180 Newton force is directed up to the left, so it's angled with the positive x-axis counterclockwise, which is the positive direction of angle is 90 degrees plus 25, so that's 115 degrees. Again, the angle that the 180 Newton force makes with the positive x-axis in counterclockwise direction, which is positive, is 90 degrees plus 25, 115 degrees. So for the solution, f is written in vector form as 180 quantity cosine of 115, 90 plus 25. So 180 quantity cosine of 115 degrees I plus sine 115 degrees J, or 180 cosine 115 degrees I plus 180 sine 115 degrees J. While the unit vector of the U direction, it makes an angle of 50 degrees counterclockwise with the x-axis, is simply lambda of U, which is equal to cosine 50 degrees I plus sine 50 degrees J, because it is a unit vector. The magnitude is 1. Then for the V direction, because U and V are perpendicular to each other, so 50 degrees plus 90. 50 degrees plus 90 is 140 degrees. So lambda of U is cosine of 140 degrees I plus sine of 140 degrees J, where 140 is 50 plus 90 degrees. So Fu is the dot product between F and lambda U. So Fu is equal to F dot lambda U, while Fv is F dot lambda of V. Remember the application and the expansion. This is magnitude of F, magnitude of lambda U, which is 1, cosine of the angle between F and U. If you expand Fv, F dot lambda B, this is magnitude of the force, magnitude of lambda V, which is 1, cosine of the angle between F and V. So it's simply Fu, the component of F in the direction U, and this is Fv, the component of V F in the direction of V. So substitute Fu equals quantity 180 cosine 115 degrees I plus 180 sine 150 degrees J dot cosine 50 degrees I sine plus sine 50 degrees J. Remember that product I dot I is 1 while I dot J is 0. J dot I is also 0. So we simply obtain the sum of the product of 180 cosine 115 and cosine 50 degrees, then plus 180 sine 115 degrees, sine of 50 degrees. So that is Fu is 180 cosine 115 degrees times cosine of 50 degrees, I dot I, which is 1, not shown here, plus 180 sine 115 degrees, sine 50 degrees, J dot J, which is also 1, not shown here. So using the calculator, Fu can now be evaluated 76.07 newtons. While Fv is equal to the force 180 cosine 115 degrees I plus 180 sine 115 degrees J dot lambda V, which is quantity cosine 140 degrees I sine 140 degrees J. So it is 180 cosine 115 times cosine 140 degrees plus 180 sine 115 degrees sine of 140 degrees. So Fv is equal to 163.1 newtons. Then the easiest way is imagine a right triangle here, this one. Then this is Fu, and the angle the angle between the force 180. So imagine this right triangle here from the tip of the force to perpendicular to you. This component here is Fu. The angle between 180 newtons and that component Fu is equal to, because this is 40 degrees, 90 minus 50, 40 plus 25 is 65. So Fu is 180 cosine of 65, 40 plus 25. So another way of computing Fu using the right triangle, imaginary 180 cosine of 65. So Fu is 76.07 newtons. Then Fv on the other hand is, because the total angle that V makes with the y-axis is also 50, because U and V are perpendicular to each other. So this is already 40, so this is 50. And since this is already 25, so this is also 25. This is Fv in the direction of the positive V direction, therefore Fv is also positive. So Fv is 180 cosine of 25. This is 25 degrees. And it is positive. Fv is 163.1 newtons. Then for your part, this is the force. These are the U and the V axis. Solve this in two methods, two ways, and show that Fu is equal to negative 263.1 newtons and Fv is equal to 95.77 newtons. So that's it for your part.